All right, so good morning. We're going to start static electricity today. And static electricity is going to be a few lectures, and then we'll go on to regular electricity. Before we embark on the study of static electricity, we have to discuss the atom. Um, you have to know the structure uh, of the atom and you know what make an atom. Okay, so the earlier philosophers and physicists um, came up with the idea that the building block of matter is a very tiny particle, and that particle was called the atom. So an atom is really the building block of all matter, and you have different types of atoms, but it is the smallest divisible or indivisible structure. So when you break down any matter, any material, the smallest part of that matter which cannot be broken down anymore, they call that the atom. And this is just an example of a molecule. So oxygen molecule, uh, which is made up of two oxygen atom combined together. So when you break down this oxygen molecule, you get the oxygen atom. Okay, the oxygen atom has a specific structure, and we're going to look into that structure. But to get a molecule, you have to combine atoms. And for the oxygen molecule, we combine two oxygen atom. Okay? Those of you who do chemistry will have a little bit better understanding. This is the caffeine molecule. And you can see that this molecule is made up of several different atoms. So if you were to break down this molecule, you could get the individual atom, such as you can see that there are some carbon atom, there are some hydrogen. Uh, there there's let's see, there is no hydrogen atom. Okay, there is a nitrogen atom. So nitrogen atom, you have oxygen atom, and you have methyl radical. And we will explain why we call it a radical. But this caffeine molecule is made up of several different types of atom combining together. If you break it down, then you get the atom. We're going to look at the structure of these atoms, okay? But before we look at that, there's a number of philosophers and physicists who did some work in this area. One of the earliest philosopher was Boyle, philosopher and physicist. He did a lot of work in gaseous substance, and he was able to elucidate the different types of atoms, and he called these elements. So you know the elementary table, or the periodic table. Okay, so he said the different types of atoms, the oxygen, the carbon, the hydrogen, he called these elements. And then Dalton in the early 1800s conducted experiments to show that there are different types of different elements can combine in a fixed ratio of masses to form compounds, as I've shown you. The caffeine is made up of different types of atoms. And then J.J. Thomson, British physicist at the end of the 19th century, did some cathode ray experiment, and he came up with a negatively charged electron. The electrons are negatively charged, and he sort of bring light to the structure of atom, to sort of what we come to know as the structure of atom. But Ernest Rutherford, who did um, tremendous work in this area, where the so-called gold foil experiments. He discovered the nuclear model of atomic structure. That is, you have a densely packed nucleus, and surrounding the nucleus, you have electron shells or electrons. So the densely packed nucleus is positively charged and it contains protons, and then it is surrounded by these negative charge electrons. So Ernest Rutherford did most of the work in this area. Niels Bohr, um, in 1913, he did uh, a lot of work in this area and came up with the sort of electron shells. So he said that electrons were confined to specific orbits of fixed radius. That is, you have the nucleus. So in the atom, you have the nucleus, and the nucleus contains protons, which are neutrally charged, sorry, protons which are positively charged, and neutrons which are neutrally charged. Then surrounding this, you have electron shells. And then at each, so you have different types of electron shells, or different electron shells of different radius. And then on each shell, you have a specific amount of energy they call quanta. So each orbit has its own discrete level of energy, and that they call that quanta. So just like how the planets rotate around the sun, you know, and each planet have a specific orbit. That is how the electrons rotate around the nucleus. So this is the model that Rutherford and Bohr came up with. So you have the nucleus, which is in the center. It's tight, it's dense, tightly packed with positive protons and neutral neutrons. So this is the nucleus. And then surrounding the nucleus, you have at different orbits, at different radius, you have these electron shells. So electrons are rotating around the nucleus. Okay, the protons are positive and the electrons are negatively charged. Okay, so that's very important. So this is the current structure of the atom, with the nucleus densely tightly packed, the center, then the electron shells, which is rotating around the nucleus. But what we're saying is that for this orbit of electron, it has a certain amount of energy. Okay, and then the outer one have a different amount of energy as well. What we're going to show you later on is that for each orbit of electron, the energy is different. So not only different, but for the outer layer of electrons, so the electrons in this orbit going to have a higher energy than the electrons in the lower orbit. Okay, higher energy electrons outside, lower energy electrons inside. Okay. Again, so let's look at this. Let's look at the carbon atom. The carbon atom, it has a nucleus which contains 6 protons, and remember, protons are positive, neutrons are neutral, and then you have the electron shells around it. So you have 6 protons. For you to have a neutral carbon atom, you have to also have 6 electrons. Electrons are negative. So you have 2 electrons in this orbit, okay, and then 4 electrons in the outer orbit. Remember that the different orbits contain different quanta of energy, different amount of energy, okay? The ones that are closest to the nucleus have lower energy. The ones that are outer have higher energy, okay? So this is the carbon atom. Again, when we look at the oxygen, atom, then the nucleus, densely packed nucleus, which contains protons which are positive, neutrons which are neutral, and then electrons in the different electron shells. So it contains 8 protons in the nucleus. It contains 8 neutrons and then 8 electrons. You have 2 in the lower orbit, and then in the outer orbit you have 6. Okay, or the outer electron shell. So this is a neutral atom because the number of protons which are positive equal the number of electrons. So it is neutral. Okay. What Niels Bohr actually came up with is that the orbits are not neatly arranged around the nucleus. They're actually three-dimensionally, they are going in these type of directions, even though they're still orbiting the nucleus, but it is not just, you know, a circle. It is a circle, but at different dimension. Okay, so this is the actual structure of the nucleus with the electron shells around the nucleus. But the nucleus again contains protons and neutrons. The protons are positive and the neutrons are neutral. Then the electrons rotate around the nucleus in these electron shells. Okay, so this is the actual structure. Let's look a little bit more on the atom. As we said that, you know, each element is distinguished from each other by the number of protons in the nucleus and the electrons to some extent. But each element is different from the next. So your carbon atom, which we're calling the element, is different from the oxygen, which is different from the hydrogen, by the number of protons in the nucleus. Remember that the nucleus contains protons which are positive and neutrons which are neutral. So the hydrogen atom has 1 proton, okay? And when you look in your periodic table, you can identify it, okay? So the hydrogen atom, 1 proton, the carbon atom, 6 protons, and the oxygen atom, 8 protons. So if you were to look at them spatially, it would look something like that. Remember the nucleus, which contains the protons and the neutrons. For the hydrogen, it has 1 proton in the nucleus and 1 electron. Remember, the electrons are in the electron shells, which rotates around the nucleus. And then for your helium, helium has 2 protons and 2 electrons. So you can see that these are electrically neutral elements because they contain the same number of protons as electrons. Okay, the electrons are negative, protons are positive. So if you have equal number, they're going to be electrically neutral. So the helium has 2 protons and 2 electrons. And then your lithium has 3 protons and 3 electrons. Remember, the electrons are in these electronic shells which rotate around the nucleus. The nucleus is densely packed. Okay? All right. So again, the nucleus contains protons which are positively charged, neutrons which have no charge, and then you have the electron shells around the nucleus. The electron shells are essentially concentric spherical regions which is around the nucleus. The negatively charged electrons occupy these electron shells. So electrons are negative and they occupy these shells. And as we have pointed out before, each shell is characterized by a distinct energy level. That means it has a specific amount of energy in each shell. The outer shell have higher energy levels and lower stability. So what you can do if you want to get energy from the atom, you can put the electrons in a lower shell and you can get energy. Okay? So if you want to get energy from an atom, all you have to do is transport the electron which is in the outer shell to a lower shell, because now you're moving from a higher energy to a lower energy. A very important point: you cannot destroy energy. You cannot, create energy. You can transform it from one type to another. So if you have a higher energy level, you can get the excess energy by moving that electron shell to a lower energy shell, and you're going to get energy from the atom. If you want to put energy into the atom, then you can move the lower energy electron shell. You can move those electrons from the lower shell to a higher shell, but you have to put energy in the system. You have to put energy in the atom. Okay? So electrons in higher energy shell can move down to lower energy shell with the release of energy, because you're moving from a higher energy to a lower energy. That energy have to go somewhere. So you can actually harvest that energy. Okay? So electron in higher energy shells can move down to a lower energy shell with the release of energy. You're going to get the atom releasing energy. Also, electrons in lower energy shell, they can move up to a higher energy shell by the addition of energy. So if you add energy to that atom, you can move the electrons in a lower shell to a higher shell. And so when we do quantum physics, we'll go into this a little bit more, but this is the basic concept. All right. So again, electron shells, if sufficient energy is added to an electron, you can move the electron from the atom. Very important. You can move electrons from the atom, but the nucleus is usually relatively stable. The nucleus, which contains the protons and the neutrons, are relatively stable. So you can't really disturb them too much. But the electrons can, you can move the electrons off the atom. Electrons can be removed or added. Very important. Okay? If you add sufficient energy, you can remove the electrons from the atom. Okay, the nucleus is relatively stable, and when we do quantum physics again, we're going to what you can do to disturb the nucleus. But for right now, the electrons are you can move the electrons. Okay, in different atoms and elements, you can move the electrons by just supplying sufficient energy. So the number of electrons that surround the nucleus will determine whether or not an atom is charged or neutral. Remember, we said that the nucleus is relatively stable. So the only thing you can move around is the electrons. So if you move electrons from a stable atom, then you're going to have excess protons, so it's become positive. If you add electrons to a stable element or atom, then you will have excess electrons. So that atom or element will be negative. So it's very important to understand that essentially the only thing you can move is the electrons. So the charge on a single proton is equal to the charge on a single electron. So the electrons and protons usually have the same amount of charge. So one electron is going to have the same charge as one proton. So if you have one proton and one electron, they sort of cancel out each other in terms of charge. So that would be a neutral element. Okay? So proton and electron have equal amount of charge, but opposite in type. Remember that the protons are positive, electrons are negative. The only thing you can essentially move in an atom is the electrons. All right. So we say an atom is electrically neutral if it contains equal numbers of protons and electrons, because they usually have the same amount of charge, but they are opposite in sign. Proton positive, electron is negative. So an atom is electrically charged if it contains, say, an equal amount of protons and electrons. So it's going to be charged if the proton does not equal to the number of protons does not equal to the number of electrons. It's going to be electrically charged. If it contains more protons, it's going to be positively charged. If it contains more electrons, it's going to be negatively charged. But very importantly, the only thing you can move in an atom is the electrons. So if it contains excess electrons, it's going to be negatively charged. If you remove the electrons from that atom, then it's become positively charged. The only thing you can move is the electrons. Okay? The nucleus is relatively stable. So the coulomb is the unit of charge, the coulomb, and the charge possessed. It is the charge possessed by an object, and we call that the coulomb. But 1 coulomb is a very large number. 1 coulomb is a huge number. As a matter of fact, when we say an object has a charge of 1 coulomb, when an object has a charge of 1 coulomb, what we're saying is that it have an excess, so minus 1 coulomb, because remember, electrons are negative. Electrons are negative. So if we say an object has a charge of minus 1 coulomb, what we're saying that object have an excess of 6.25 times 10 to the power 18 electrons. It has an excess of electrons. So if it's negatively charged, it have to have an excess of electrons. And if it's positively charged, that means it's going to have a shortage of electrons. The only thing you can move in an atom is the electrons, because the nucleus is relatively stable. So you can move the electrons. If you supply sufficient energy, you can move the electrons around. So you can add electrons. So if we say it has a charge of minus 1 coulomb, that means it has an excess to have more electrons in the tune of 6.25 times 10 to the power 18 electrons. If we say it has a charge of positive 1 coulomb, then it has a deficiency, a shortage, because it's positive. So it has to have more protons. So that means it's going to lose electrons. So it has a deficiency or a shortage of electrons of the tune of 6.25 times 10 to the power 18 electrons. Now, what is the charge on 1 electron, and what is the charge on 1 proton? Remember that the charge on the proton is the same as the charge on the electron. It's just that the sign is different. Okay? 1 electron has a charge in terms of coulomb of minus 1.6 times 10 to the power 19. Remember, an electron is a very small material, extremely small, and the charge on 1 electron is minus 1.6, because it's negative, times 10 to the power 19 coulomb. And these are numbers that you have to know. And then the proton has a charge of 1.6, positive 1.6 times 10 to the power minus 19 coulomb. Very important. So what we're going to do, we will do a few questions so we fully understand these concepts. So the protons and electrons, they provide, or they produce, or they create electric energy. Okay, opposite attracts. That means a proton and an electron will attract each other, and that is why you will have the electrons rotating around the nucleus, which is positive. Nucleus contains the protons, so the negative electron is attracted to the proton, so that's why it sort of stays in place to some extent. You can remove it, by supplying energy, but it stays in place to some extent. So the opposite attracts, positive attracts negative. The proton attracts the electrons, and then likes repel. So if you put an electron close to another electron, it's going to repel it. If you put a proton, which is positively charged, close to another proton, it's going to repel it. So likes repels. And then charged objects and neutral objects attracts each other. So an electron and a proton will attract a neutron. All right. So let's do some questions so we fully understand static, the atom. We have to understand the structure of the atom, the behavior of the components of the atom, so we can further we can understand fully static electricity. So the first question is true or false? An object that is positively charged contains all protons and no electrons. So an object that is positively charged. So again, if you have any atom, it has a nucleus and then electron shells. The only thing you can move is the electrons. So if it's positively charged, that means you have to remove electrons. So if you remove electrons from around the nucleus, you'll have more protons. So that object will be positively charged because you remove the electrons. Okay? So it's important to remember the thing that you can move from an atom is the electrons, not so much the nucleus. Okay, so again, true or false? An object that is negatively charged could contain only electrons with no accompanying protons. So atom has a nucleus and it has electron shell. So it have to have the nucleus contains protons which are positively charged and neutrons which are neutrally charged. So the object gonna have a nucleus which gonna contains protons which are positively charged and then electron shells around it. So you can't have an object that contains no protons. Okay. All right. So true or false? An object that is electrically neutral contains only neutrons. Remember, neutrons are neutrally charged, but in the nucleus you're going to have protons and neutrons. If it's electrically neutral, that means the number of electrons equal to the number of protons. If it's electrically neutral, the number of protons is going to equal to the number of electrons. The protons are in the nucleus along with neutrons, and then the electron shells are around the nucleus. The negatively charged electrons are going to be attracted to the positively charged proton in the nucleus, or the neutron, because the charged objects are attracted to the protons. All right, so question number 4. Identify the following particle as being charged or uncharged. So there are 3 particles here, and identify the particles as being charged or uncharged. If charged, indicate whether they are charged positively or negatively. And of course, N is for neutron, P for proton, E is for electron. In the nucleus, you have protons, so you have 9 protons and 10 neutrons in the nucleus. In the electron shells around the nucleus, we have a total of 8 electrons. You have 2 in the inner shell, and then the outer shell you have 6. Okay. So in the inner shell you have 2, and in the outer shell you have 8. So the outer shell you have 8 electrons, and the inner shell you have 2 electrons, for a total of 10 electrons. So you have 10 electrons and you have 9 protons. So you have an excess of electron by 1. So this particle is negatively 1 charge. So it has a charge of -1. because it has only one more electron than proton. Okay, so one more electron than proton. So the charge is -1. And then particle B, in the nucleus, you have 11 protons and 12 neutrons. Electrons, you have in the inner shell, you have 8 electrons, and the outer shell, you have 1. So a total of electrons 9. So you have protons, so you have to remove, so you actually have to remove electrons from the shell to have more protons. So when they remove electrons, they have 9 electrons, 11 protons, for an excess of protons of +2. So this particle is as an excess charge of +2 because it has more protons than electrons. Particle C, in the nucleus, it has 20 protons and 20 neutrons. And then when you look at the electron shells, this one actually you have 1 shell, 2 shell, you actually have 3 shells here. So you have 2 in the inner shell, the middle shell you have 8, and the outer shell you have 8, for a total electrons of 18, protons 20. So you have 2 more protons. So this particle has a charge of +2. Okay? So to determine if a particle is charged, you just have to add up the protons, add up the electrons, and see if you have more electrons than protons or more protons than electrons. Again, remember, the only thing you can remove from an atom is the electrons. The electrons can be removed. All right, question 5. Consider the graphic at the right of a neutral oxygen atom. So they say it's neutral. So you know if it's neutral, then the number of electrons is going to equal to the number of protons. In the nucleus of the atom, you have protons and neutrons. The protons are positive. So if this is neutral, okay, let's count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. So you have a total of 8 electrons. So you're going to have a total of 8 protons. So explain what must happen in order for the oxygen atom to become negatively charged. The only thing you can remove or add is electrons. So you have to add electrons to this oxygen atom for it to become negatively charged. You have to add electrons. Then explain what must happen in order for the oxygen atom to become positive. So you have to remove electrons. The only thing that is you can add or remove is electrons. So if you want it to become negative, you have to add electrons. If you want it to become positive, you have to remove the electrons. Okay? All right, we'll do 2 more. Okay, so determine the quantity and the type of charge on an object. This object has 3.62 times 10 to the power more protons than electrons. So it has more protons. So it's going to be positively charged. Remember what we said. The charge, so the charge on a proton, so you have to remember the charge on a proton. The charge on a proton, so a proton is positive. Proton is positive, and it has a charge of 1.6 times 10 to the power minus 19 coulombs. Remember, coulomb is a very large number. Coulomb is a very large number, so it has a charge of 1.6 times 10 to the power 19 coulombs. Okay? So it has an excess. So each proton contains this amount of charge. It has an excess of 3.62 times 10 to the power 12 more protons. So the total charge is equal, so the total charge is equal to 1.6 times 10 to the power 19 multiplied by because you have that many protons, 3.62 times 10 to the power 12. So, okay, so because each proton contains this amount of charge, you have this number of protons. So the total charge, you just multiply them. And when, so 1.6 times 3.62 is 5.79. 5.79. And when you had 10 to the power 19 times 10 to the power 12, you have to add the powers, and you get minus 7. So this is the charge. Okay, minus 7. So that's a total charge, and of course the charge is in coulombs, so you have to put your sign. Okay, so each protons have this amount of charge. You have this number of protons. So to get the total charge in this object, you have to multiply them, and you get that. All right, so let us do one more, and all right, let's all right, complete the following statements. After some rather exhausting counting, a physics teacher determined that a very small sample of an object contains this amount of protons and this amount of electrons. The charge on this object is so if it contains it, so if just looking at it, what you have to do is, okay, it has more protons than electrons, and you have to see how much more protons. So we'll do the first one, and then we'll reserve the rest when we do our next session. So it has more protons. So it has, you have to you're going to subtract now. You're going to subtract the electrons from the protons, and you're going to see how much excess protons it has. And remember that protons have positive charge. So when you subtract, so we're going to subtract from 8.25, 8.257, 749, times 10 to the power 17. You just want to find the excess amount of protons. And you're going to subtract the electrons from that. So 5.26. All right, this is a point. So that's 5.26. Times 10 to the power 14. Okay, so what you have to do when you're subtracting, you can convert this into 10 to the power 17, but you have to move your decimal point 3 places. Okay, so this would be 8.257 749. Okay, so let's put that in bracket, and then you're going to subtract from that. So if you move your decimal point 3 place to the left, then you can, this becomes 10 to the power 17, and you can put that outside the bracket. So when we move your decimal point 3 place, you'll get, so you're going to minus 0.00052626 times 10 to the power 17. Okay, so 1, 2, 3. So you just had these numbers, and so you're going to get, okay, so so this is just addition of, so you're going to add 0.25749. You're going to add that, so you have you have 2 zeros, then 526. So this is 15, 6, 7. This is 12. That's 6. And then that is 2. So this becomes 8. This becomes 8.262. Seven five times 10 to the power 17. So this is the, this is the number of protons. So to get the charge, remember each proton has a positive charge of 1.6 times 10 to the power 19 coulombs. So you have to multiply this by 1.6 times 10 to the power 19 to get the total amount of charge, because you get the number of protons and you know the charge on each proton, so you just multiply them. So when you multiply these things, so you're gonna, all right, so it's gonna be 1.6 times 8.26275, and you get 13.22. So that is equal to 13.22 times 10 to the power. So when you add these two, you get minus 2. and this is coulomb. This is the charge, total charge. Okay, so the charge is 13.22 times 10 to the power minus 2, which is equal to 0.1322 coulombs. Okay, and it's positive because you have excess amount of protons. We have more protons than electrons. So you just want to find out how many more protons you have. You know the charge on each proton. So you multiply the number of excess protons times the charge on each proton, and you get the total charge. And it's going to be positive because you have excess amount of protons. So we're going to leave it there, and then when we do our next session, we'll continue with the rest, because in order for you to do static electricity, you have to go through this motion. You have to know if you have excess protons, you have to calculate the charge. If you have excess electrons, you have to calculate the charge. Okay? Again, opposite attracts, like repels, charge and a neutral is going to attract. Okay? So we'll stop here.